We shall see the next problem on the leaf spring. A semi-elliptical multi-leaf spring is used for the suspension of rear axle of a truck. It consists of 2 extra full-length leaves and 10 graduated leaves, including the master leaf. The center-to-center distance between the spring eyes is 1.2 meter. The leaves are made of steel with sigma Yt, that is yield stress is equal to 1500 MPa, and they have given capital E, Young's modulus is equal to 2.07 into 10 power 5 MPa, and FOS is equal to 2.5. The spring is to be designed for a maximum force of 30 kN. The leaves are pre-stressed so as to equalize stresses in all leaves. Determine first one cross section of leaves, that is cross section means width and thickness. Initial nip is the distance between the two leaves, that is full length leaves and graduated leaves. We had found out it is C. This is known as nip distance, or this is known as nip distance, and the process of bolting these two and creating this C is equal to 0 is known as nipping. And the last one is initial pre-stress required to close the gap. Now we shall see a multi-leaf spring for suspension of rear axle of the truck. It consists of 2 extra full length leaves. So full length leaves is IF is equal to 2 and 10 graduated leaves, including the master leaf. So graduated leaves is 10. So the total IF plus IG is equal to 2 plus 10, it will be 12. The center to center distance between the spring eyes is 1.2 meter. So the center to center distance, it will be, we shall take it as 2L is equal to 1.2 meter. The leaves are made of steel with sigma Yt, yield stress 1500 MPa. Sigma yield stress 1500 MPa. And E is equal to 2.7 into 10 power 5 MPa. FOS 2.5. So FOS is equal to sigma yield stress by sigma allowable stress. Yield stress they have given 1500 MPa. So we shall find the allowable stress. Allowable stress is 500 divided by 2.5. It will be 600 MPa. The spring is to be designed for maximum force of 30 kN. So F is equal to 30 kN. The leaves are pre-stressed. So here for F they have not given the central load. So if they have given the central load on the leaf spring, then we have to take 2F. They have not given the central load. They have given only the maximum stress or maximum force is 30 kN. So we shall take it as F. The leaves are pre-stressed. So here they have given the leaves are pre-stressed so as to equalize stresses in all leaves. So if pre-stressed condition is given, we have to take this, the maximum stress in spring with full length leaf pre-stressed. So this is the stress condition for pre-stressed condition, and this will be the original cross section of the leaves before pre-stressing. So for pre-stress we shall take sigma F is equal to sigma G is equal to 3FL by IB dash H square. So this is from equation 11.32C, page number 182. Here we have found out the allowable stresses. So this will be equal to the stresses in full length leaves and stresses in graduated leaves. Here they are given the length between the two eyes, that is the distance between the two eyes of the leaf spring. So we shall take it as L by 2. They are not given the distance between bolts, so we shall take it as L by 2 directly. It will be 600 mm. I is 12 into B dash h square. We are unaware of B dash and h square, so we shall keep it as it is. So on solving this equation, we will get the value of B dash h square is equal to 7500. Here in this problem, they are not given the deflection y to calculate B dash h square. So that is why we need to assume one of the values here. We shall assume the value of B dash as 60 mm from standard table 198, page number 198, table 11.10a, the normal size of flats. So width and thickness. Width I am going to assume as 60 mm. Width I am going to assume as 60 mm. So from the above equation, we shall write here table 11.9, 11.10 a, page number 198. So if B dash is 60, then h square is equal to 7500 divided by 60. The value of h will be 11.8. We shall approximate it to 12. So from table 11.10, again the same table. So the thickness standard values is 10, 12, 14. So we have got the value as 11.8. We shall approximate it to 12 mm. Again from same table 11.10a, page number 198. Now they have asked, so first condition we have found out the cross section of leaves. So next condition, initial nip. So initial nip is C, and the process of decreasing the value of C to 0, that is clamping, is known as nipping. So we shall take C as FL cube by I H cube E B. So this is from 11.32a, page number 182. Here the important message is that the B here, it is not given in this data handbook. So I have assumed the old data handbook and I have considered the formula. So in old data handbook they have given the value of B here. So we need to add B here. So the value of C is F is 30 kilo into L cube is 600 mm. I is 12. H is also 12 cube into E is 2.07 into 10 power 5. Into the value of B is 60. B or B dash. So this equation we have already written. The value of C which I will get by solving this equation is 25.16 mm. 25.16 mm I will get. Next we will find the last condition, initial pre-stressed preload required to close the gap. So here we can see the load on the clip bolts to close the initial gap. So this is the load they are applying on these bolts to close the gap between the full length leaves and the graduated leaves. So that is FB is equal to so this is from 11.32b, page number 182. Two into 10 into 30 kilonewton I is 12 into 2 into Ig 10 plus 3 into If. So the value of FB which I'll get is 1923.08 newtons.